Hello. Can we zoom in? Good evening, everyone. Good evening, Silong. Good evening. How are you, Silong? I hope you all good. And there were total of 3 to 4 days off for Diwali vacations. I hope you all enjoyed it, right? So now we will again start with the last topic of GP of, I would say, sequential series, right? So in that, what we have covered, first of all, let me tell you one by one. First of all, what is AP, right? Sum of AP, AM. Then we have understood what is a GP, geometric progression, right? How to insert any GM, geometric means, right? All these sums of geometric means, right? Including infinite series, right? Where your capital, I mean the small r, not capital R, not small r, right? So common ratio value should lie between -1 to +1. We're talking about infinite series. So all those questions we have done. In the last class, we have also covered what is AM and GM, what is the relation between AM and GM. So in that topic, we have covered some questions, right? That AM is greater than always GM or equals to GM. AM is greater than or equals to GM. Now, it is always greater, but it will be equal. It will be equal, or I would say equality will be hold when numbers are equal. Suppose if we have two numbers A and B, right? So it's AM and GM both will be equal if these two numbers are equal. Is that clear? So this is all we have covered, right? Let's do one question. Again on AM and GM. Silong, I'm not getting any response from Silong. Is there anyone in Silong Center? Please, if you are there, please mark your attendance and let me know if you can hear me, you can see me clearly. Then only we will start. Silong Center. Okay, two students, okay. Welcome both of you. So first of all, tell me if you have any doubt. Any doubt in AM, GM, AP, GP? Or including exercises 9.1, 9.2 from your NCERT, right? 9.2, 9.1. Please respond something. Okay. I hope there is no doubt. So then I will start. There are a lot of questions which you should ask, but you are not asking, so I would not discuss. Right? I'll go ahead. Question number 16. I'm very happy that you asked. Question number 16, Silong. Definitely we will discuss. Question is, let me know if I'm getting the same question, okay? Find a GP for which sum of the first two terms is -4 and the fifth term is 4 times the third term. Let me write the question. Those who have not using NCERT. Question is, find a GP for which sum of the first two terms is -4. And the fifth term is 4 times the third term. The third term. Okay, miscellaneous exercise. All right. But I think there is so much to do before miscellaneous, right? Anyway, 9.4 was there, right? 9.4 you have to do first. There is miscellaneous series. Again, spatial series is there, right? And like in the last class, we have covered this topic called sum of first and natural number, then sum of squares of first and natural number. So all these will be involved. I'll tell you, don't worry. Miscellaneous. Okay, I'll come to 16, but before that, let me finish some important topic like this 9.4 first of all, right? Okay, Silong, can I first do 9.4 exercise? Okay, thank you for your patience. I'll definitely discuss question number 16 and whatever you will ask. Okay, thank you. So let's start with some important series like AGP. What is AGP? This is not in NCERT, but I'll take only 10 to 15 minutes in this topic. Maybe you will get this kind of question in some IIT JEE Maths exam. Very easy. Let's understand what is AGP first of all. AGP is basically, as the name itself says, arithmetico geometric progression. Okay? Arithmetico geometric progression means in this particular sequence there will be total of 2 types of pattern. First, arithmetic, that means difference will be constant, and also G means geometric progression, means common ratio would be same. You see, for example, if I were to ask you find this sum, S equals to x plus 3x square plus 5x cube plus 7x raised to power 4. See, this is my sequence, right? So what I'm asking is that x plus 3x square plus 5x cube plus 7x raised to power 4, you have to find this sum. Okay? Infinity, where mod x is less than 1. That means, okay, let me tell you one by one. First of all, you have to understand there are 2 things. Some are numbers present, like 1, 3, 5, 7. Is there any pattern they follow? Yes. 1, 3, 5, 7. They all make AP. What about this x, x square, x cube, right? X raised to power 4. They will together make a GP. And combination of these two, we call it AGP. Now, what we do in this kind of progression in this spatial series, very simple method, right? We have to follow simple steps. Let's find out this sum. Okay, this is my question. So what we will do, let's multiply with the common ratio. What is the common ratio of this? Of course, x, because x square upon x will be x. So common ratio of the GP is x. Now, let me write this question. Find the sum. S equals to okay. So how we will solve this? We will multiply with the common ratio of GP. What is common ratio of GP? Which is x. So I'll multiply with x. Okay, I'm saying this is equation number 1. And here, after multiplying with x, what we get is x square. Right? This term will be x square. But I'll not put here, right? But I'll put here in the like term, just below the like term, the like power. Okay. Now, what is this? When you multiply this with x, it will become 3x cube. So, here it is 3x cube. Keep going. This is 7x raised to power 4. This will be how much? 5x raised to power 4 and so on. Is that clear? Right? Is that clear? Now you see. Let's say this is equation number 2. 1 minus 2 gives 1 minus 2 gives 1 minus x times s equals to, this is how much x? Only x, right? When you subtract this, it will be how much? 2x square. This is how much? 2x cube and so on, right? 2x raised to power 4. As the last term is infinity, so that doesn't make any difference, okay? So, just that distance will be enough. 1 minus x times x equals to, this is odd, this is x plus, you see, now what the pattern we are getting is 2x squared, 2x cubed, 2x raised to power 4. So now you have to understand what is the, why we have done this, like why we have multiplied with x and then we have shifted a term, right, below the like powers. The reason being, when you subtract this, the effect of AP will be damaged. You see, here, it was 1, 3, 5, 7, but after doing this, you see, we are getting 2, 2 and 2 and 2. It is banished now. Only GP will be there, right? So if I take 2x square common, it will be 1 plus x square plus and so on. Right? Now guys, what is this sum? X plus 2x square. We know this is a GP. If x is less than 1, so it will be an infinite GP with common ratio less than 1. Formula is A upon 1 minus R. So A is 1 upon 1 minus R. Is that clear? Now you have to solve this. Whatever the value of S, that will be your answer. 2x square upon 1 minus of x. If you were to solve it further, it will be x minus x square plus 2x square divided by 1 minus x times s. Right? What is the value of s finally? It will be x plus of x square divided by 1 minus x to the whole square. See, basically this thing will become how much? X plus of x square divided by 1 minus x. And if I take one more 1 minus x, it will be 1 minus x to the whole square. So whatever the answer you can see is the answer, right? Don't get afraid of these x square, 1 minus x, right? Of course, if I'll give you some value, you can find out your answer in the numbers. Method is very easy and very important. What we are doing is, we are multiplying with the common ratio of the given GP. And we are putting the terms with the like powers, below the like powers. And when you subtract 1 minus 2, it will give you simple GP. Right? Then after you have to put the formula, you have to apply the formula of summation of GP and you can find out the answer. Maybe there are some question in which you will get n number of terms, 15 number of terms, right? So accordingly, you have to solve. Method is still same. Okay? Method is same. Silong, did you get it? Silong, please come with your doubts. Great. Okay. Then I'll give you one question that you can solve, then we will move ahead. Okay. Now one question for you. Question is, find the sum S equals to half plus 4 into 1 by 4 plus 1 by 8 plus 10 into 1 by 16 and so on till infinity. Find out the sum. I think question is clear in itself, right? And the way I have presented to you is quite easy because I have mentioned this multiplied thing. So you can separate actually what is the AP thing, what is the GP thing, right? Separately. 1, 4, 7, 10, they are in AP. Half, 1 by 4, 1 by 8, all these are in GP. So accordingly, you can solve. You have to find out the common ratio of GP, that is always, right? The next term divided by the previous term, always. Okay? I hope you are solving this way. Let me check. Let's consider this given as 1, right? Now what is the common ratio? It will be 1 upon 4 divided by half. So what we get? We get half, right? So S is the half is the common ratio. Now I'll multiply with half, right? Now after multiplying with half, how I will do it now? See, 1 by 2 into 1 by 2. So it will be here 1 upon 4 plus of. Okay. Let me make it more, compatible. If we write it as, let me write as 1 by 2 plus 4 into 1 by 2 square plus 7 into 1 by 2 cube plus 10 into 1 by 2 whole 4, right? Now if I multiply with half, what I can write? 1 by 2 square plus 4 into 1 by 2 power 3. Then we get 7 times 1 by 2 to the power 4 and keep doing. Okay? If I mention some term, suppose I'll say 14 terms, so accordingly you have to write here what is the 14 term, right? Because last term is always required if number of terms are finite, always remember, right? Now we subtract these two, what we will get? We will get half of S equals to, this is what? Half plus, this will be 4 times, this is 1 time, so we will get 3 times 1 by 2 whole square. Similarly, it will be how much? 7 minus 4, so again 3. I think we can take this 3 common in the same step. You agree? So if we take 3 common, it will be 1 by 2 to the whole square plus 1 by 2 to the power 3 plus and so on 1 by 2 power 4. Keep going. We are taking as infinity, so nothing to worry about. It will be S by 2 equals to, this is half, this is what? Thrice of, you see, if I take 1 by 4, more 1 by 4 common, then it will be 1 only. So 1 upon 1 minus R. Half plus 3 by 4 into, this is 2. This overall value is 2, okay? Always remember this sum will be 2. So this is 2. What we are getting? 3 by 2 plus 1 by 2, which is 2. Hence, S equals to, the value of summation S, capital S, will be 4. So this comes out to be, this sum comes out to be 4. Is that clear, everyone? Simple method, simple approach. Again, the same thing, find out the common ratio and multiply with it and then subtract it. Okay? Ask me if any doubt. Any doubt, anyone? No doubt. No response means no doubt, right? All is well. All is well. Okay then. Coming to 9.4, let me write 9.4 exactly, because this is quite special, because there is no concept we will be using of AP or GP directly. Okay? Maybe indirect use may be there. So let me see you the first category. Right? Or I would say type 1. You can name it type 1. Name is spatial series. NCERT exercise will be 9.4 type 1. Type 1. Find out this sum. If I ask you find out this sum, which is given as 1 into 2 plus 2 into 3 plus 3 into 4 plus, right? What will be the sum? Let me take AND terms for now. So 1 into 2, 2 into 3, 3 into 4, and so on. Every term is in this pattern. 1 into 2, keep increasing. 2 into 3, 3 into 4, 3 into 4, 4 into 5, and so on. Right? Now, there are two methods to solve this kind of problem, right? But the easiest method, I'll start with the easiest method, okay? The method in which we will use these formulas, sigma r square, sigma r cube. I hope you remember, all of you. How we do that? Now you see. First of all, we will write the step 1. We will write the general term. Write down the general term. Okay? Write down the general term, which will be in terms of r, which is in terms of r. Step 2, apply summation or sigma, right? Apply summation or sigma from, I mean, that depends. If you are starting with r equals to 1 to r equals to n, so accordingly you have to put r equals to, I would say some r equals to any value you can take, like some r equals to 1 to r equals to n. Just in general I am taking r equals to 1 to n. That is not necessary that always you will start with r equals to n. Right? There will be some value of n definitely, but not necessarily r will be n. I mean, the initial value will be 1. That we will discuss, don't worry. So this is more or less you have to do step 1 and step 2. Now you see how we do this. We have this s equals to 1 into 2. So what is this term, guys? This is t1, right? This is bacho t2. This is what? t3, and so on. Now, can you tell me what is tr? Any general term, tr. When this is 1, first term. In first term, we get this 1, this is 2. So if this is 2, this is 2 into 3. So if I take any tr term, that will be r times r plus 1. Right? Okay? R times r plus 1. Let's multiply this. This will be r square plus of r. tr will be r square plus of r. This is your general term in terms of r. Now, if we apply summation, it will be Sn will be nothing but summation over tr, which is r square plus r, varying from r equals to 1. As in this case, you have to put r equals to 1 to get the t1 term, right? That will be 1 into 2. When you will put r equals to 1, the very first term you will get, that will be 1 into 2. And the last term required is n, tn term, right? Now, we are almost done. You see, what we are doing is finding Sn. Now, what is, guys? R square. What is sigma r? We can break these two operators, right? 2 plus 3 is equals to 5. 4 plus 1 is also 5. Addition, simple addition, okay? R equals to 1 to n. R equals to 1 to n. Now, what is r square? Summation of first natural, from summation of squares of first natural number. That is always n times n plus 1 times 2n plus 1 divided by 6. Okay? Plus of n into n plus 1 upon 2. As it is varying from n, from 1 to n, so it will be directly in terms of n. Otherwise, suppose we have n equals to 10, so here you have to put the value of n equals to 10. Okay? Now, what is Sn, guys? Sn will be, can we take something common? Yes, definitely. N times n plus 1 by 2 we can take common. If we do so, what we are left with? 2n plus 1 divided by 3 from the first term and 1 from the last term. So what we get? N into n plus 1 upon 2, and this whole will be twice of n plus 4 upon 3. Okay? And if we take 2 common, this is 2n plus 4. Sorry, let me write this way. 2n plus 4. It would be clearly observable. If we take 2 common, it will be n plus 1, n plus 2, right? 2 we have taken down, right? So 2 gets cancelled. Divide by 3 is the answer. One more time. What we are doing in this case, we are writing down the TR first of all by observing the given terms, by identifying the pattern involved, right? So once you will write TR, that will be in terms of R. Now if you are lucky enough, what maximum you will get? Suppose if we have 3 terms, I'm saying in a single term, if you have 3 numbers, suppose if I were to do 1 into 2 into 3, suppose 1 into 2 into 3, then of course there will be R, some R and some other R. So total of R cube maximum. So that you know how to solve R cube, that you know, right? So R or R square or R cube, all 3 you can solve anytime. Problem is with when you have in a single term, there will be 1 into 2 into 3 into 4. Now it will be R raised to power 4. We do not know any kind of formula for this. Well, anyway, that would not be asked. Don't worry. Okay? I've just told you the limitation of this method, right? Limitation. It is only applicable if you are solving power of 3, R cube. Is that clear, everyone? What we are doing is we are finding the TR, then we are simply applying the SN formula, which is nothing but sigma operator from the initial limit to the higher limit, lower to higher limit. Okay, make sure when you are applying these formula, you have to write down your term in such a manner that it will start from r equals to 1. Otherwise, you cannot apply the formula. I hope you're getting this point. We will do some question. Don't worry. Any doubt, anyone? Tell me any doubt, Ceylon? No, great, great. Let's move ahead then. Next question is, you can solve this one. S equals to 1 into 3 plus 2 into 4 plus 3 into 6 and so on. 3 into 5. Okay? First one. I will tell you how to write TR, that you can solve, I guess, right? Because it will take a lot of time if I am going to solve it completely. So better to make a lot of, to conclude a lot of questions rather than doing it completely. If S is given 1 into, let me take any random figure, 1 into 2 into 4 suppose. So again, if I take 3, if I am taking 1 difference 3 into 4 into 6 plus 5 into 6 into 8 and so on. Okay? This is 10 into 12. So there are a total of 10 terms. Okay, now see, again this is what T1, you should do this, right? You should write T1, T2, T3 so that you can find out what is this term. You can identify the position of this last term. As this is 1, so this is 1. This is 2, so this is 2. That means it must be T10. Right? And does the pattern being followed by all the term? Yes, 1 into 3, difference of 2. 2 into 4, difference of 2. 3 into 5, so again 5 minus 3 is 2. Lastly, 10 into 12, 12 minus 10 is again 2. So, we can apply the same method, right? Now you see, S equals to, before finding Sn, let's write TR. What is TR? TR, guys, it will be R times R plus 2. Quite simple, okay? R plus 2. TR is R square plus of 2R. What is S10? It will be sigma R square plus sigma. Twice I can take 2 common, it will be twice of R. R varying from 1 to 10, R varying from 1 to 10. Rest you can solve. Rest you can solve, okay? Simple. You have to apply the formula of sigma R square and then put n equals to 10 in the formula. You will get the answer. This is first one. Let me do second. That will be good enough. Anyway, take your time, and when you are done with the writing part, please tell me. Let's identify what is TR now. Okay, TR. What is TR? 1 into 2 into 4. So if this is T1, this is T2, this is T3, guys, we have to find out summation of n term. So don't worry about that, will be n. The upper limit is n. What is TR? Help me with TR. This is 1, so this is 1. That means if this is R, this will be R. Always take some help from the very first number of this. R. Then it is what? R plus 1. R plus 1. Then it is R plus 3. Because R is 1 for us, right? This will be R plus 1. This is R plus 3. So this is R plus 3. Is that clear? So what is TR now? TR will be R times, this is what? R square plus of 4R plus of 3. On solving this, we will get R cube plus of 4R square, okay, plus of 3R. This is value of TR. This is your TR, right? Now I think you can solve for SN, right? You have to simply apply the formula of R cube, R square and R. Is that clear? Please ask me if you have any doubt. And in this case, always remember you have to put from your limits will be R equals to 1 to n. Whether it is R cube plus 4 times R square or 3 times of sigma R. Limits are always 1 to n. The rest is only you have to find out the answer, right? I think that you can do it, all of you, okay? So after some 2 or 3 steps, you will get the answer. Let me know if you have any doubt in this particular, because now I'll move to the next type of this. It is all about writing the general term, understanding the pattern. I hope you are getting it, right? You have to find out the pattern, right? You have to identify how the numbers are being changed, right? In T1, what are the numbers given, how they are varying in the term 2, then accordingly term 3, right? And always do not just start with the, while just looking at T1 and T2, right? You should always consider at least 3 terms. T3, at least three terms. Because to identify any kind of pattern, we need or we require at least 3 number of terms, not 2. Right? Because if I ask you, suppose 2, 4, what is the sequence? Now someone will be saying, sir, 2, 4, 6. Someone will be like, sir, 2, 4, 8. 2, 4, 6 is the AP, 2, 4, 8 is the GP. So there are a lot of possibilities comes out of this, right? But if I give you 2, 4, 8, now it is restricted to GP only. Is that clear? So always remember, whenever you are identifying any kind of pattern, you will always look for at least 3 terms. Okay. Next is type 2. Let me give you some example for this. Example will be like this. Find the summation of 1 upon 1 into 2 plus 1 upon 2 into 3 and so on. N terms. If it is nothing given, then of course you have to consider 1 into 2, 2 into 3, then 3 into 4. Okay. But a nice observation is if they give you actually 3 terms. A good quality question, I would say, when it is provided 3 terms at least. So how we would find this kind of sum? You see, of course, there will be someone who's thinking, sir, can we apply this again TR funda, right? 1 upon TR. I mean, if TR is, in this case, TR can be written as very easily R into R plus 1. I agree, totally agree. But you will not get any kind of summation, spaces series for this. 1 upon R square plus R, what after that? There is no formula for this, right? We have formula for summation of first and natural numbers, not for the summation of reciprocal of natural numbers or anything reciprocal of any square or cube. Is that clear? So this is not valid, right? This is not valid. This is not helpful in this. So what we can do now, there is a different approach for this. What we will do is, we will write the difference of these two terms. We will split them, right? How many terms are given in the denominator? 2 terms, right? So again, first of all, again we have to write TR. So let me write TR. This is TR, right? This is TR. TR is nothing but 1 upon R into R plus 1. Now what different approach we will follow? What we will do, we will split these two terms something like this. 1 upon R plus 1. Right? 1 upon R plus 1. Partial fraction we are doing basically, right? Splitting them. You should always check whether these two are correct or not, whether these two are equal or not. So yes, if you were to solve this, right? If you were to solve this, what you will get is, in the denominator R plus 1, okay? What is in the numerator? It will be R plus 1 minus of R. R gets cancelled off. We are left with 1 upon R into R plus 1. So yes, these two are same. Always remember, guys, you have to do this. Don't worry about the number what we have to multiply or we have to divide. Always you will split in this way, like 1 upon R plus 1. You will understand what is the reason behind this, why we are doing this way. Okay. Now let me write here. First of all, TR is 1 upon R minus of 1 upon R plus 1. This is TR. Let's find out T1. T1. What is T1? T1 will be when n equals to 1. When R equals to 1, you will get T1. What is T1? 1 upon 1 minus of 1 upon 2. R equals to 2, you will get T2, which is 1 upon 2 minus of 1 upon 3. Let me put R equals to 3, guys. R equals to 3. What you will get? You will get T3 equals to 1 upon 3 minus of 1 upon 4. Keep doing this, keep doing this. Okay. Let me put R equals to n. So what we will get? Tn equals to 1 upon n minus of 1 upon n plus 1. Anyone, what is Sn? Sn is T1 plus T2 plus T3 plus T4 and so on till Tn last term. These are nothing but T1, T2, T3 till Tn corresponding to this TR. If we were to add them together, right? Add them. So what we will get? When you will start adding them, this minus half plus half will cancel. Minus 1 by 3 plus 1 by 3 will cancel. Are you sure? Minus 1 by 4 will be cancelled with the next first term of 1 by 4 plus? Yes. Right? Similarly, the last term will be like this. This will be cancelled. What we are left with? We are left with Sn equals to 1 upon 1. You know, here this is 1 upon 1 minus of 1 upon n plus 1. This is what you will left with. So this you can solve, I guess, right? So that will be n plus 1 minus 1 upon n plus 1. So that we will get n upon n plus 1. Very important series, very important. My recommendation to you, if you can remember, please, you can remember it. Very much important. I mean, so many direct questions I can ask you. For example, if I can ask you, if I were to ask you, what is this sum? 1 upon 1 plus 2, 2 into 3, and so on, 99 into 100. So I think you can directly answer this. If you remember this formula, n upon n plus 1, so the only thing is, what is value of n? Value of n is 99. Starting from 1, then 2, then 3, and so on, the last term is 99, right? So if last term is 99, what is the answer? 99 upon 99 plus 1, that is 100. This is the answer. Well, anyway, this is, if you remember the answer. Otherwise, you should admire the approach, and you can remember this approach. That will be more important. What we are doing, guys, one more time, we are writing the TR first of all, and then we are splitting it, right, in the difference of two consecutive terms. Difference should be consecutive, right? Now, we should always check whether the split is being done correctly or not, or there is something we have to subtract or divide. I'll tell you, I mean, something we have to multiply or divide. I'll tell you what exactly I'm talking about. But for now, tell me if you are clear with this or not. Any doubt, anyone? Please ask me your doubts. Clear. Very good. Very good. Then you can solve this question. Question is, you just tell me what is the TR and how you will split that, right? That is the most important thing. S is 1 upon 3, 2 into 4, 3 into 5. Find out this sum. Try your best, right? Keep trying your best. 1 upon 1 into 3, 1 upon 2 into 4, and so on till 1 upon 49 into 51. So, of course, how many terms are there? That is 49. 49 terms. Total of 49 terms. Okay? The main challenge is to split the TR, right? Not writing the TR. That everybody know. Okay, so what is TR? TR is 1 upon R into R plus 2. Okay, R, if R is 1, so this will be R plus 2. So 1 upon. So basically when there is terms in reciprocal, or I would say numbers are in reciprocal, then we will not directly apply summation, right? That operator, sigma operator, but we will actually split in the difference of two consecutive terms. So let me split it, right? 1 upon R minus of 1 upon R plus 2. Okay? Are these two same? Because we are writing it down, that's fine, but you have to check whether these two are correct or not. So let me solve this. If this is R plus 2, so it will be R plus 2 minus of R. No, this is not correct because we are getting R upon R plus 2, but twice. What we are given with? Only 1. So if there is extra 2, we have to divide with 2. So let me divide with half. Now this will be correct. I mean, these two will be equal. I hope you're getting it. This is the most important thing. Once you will understand, you will never get doubt. Why we are dividing by 2? Because the difference in the numerator will give you extra 2. So that you have to balance. Only in this step, right? So that will be divide by 2. Rest is we are done, right? Let me write TR. What is TR? Half of 1 upon R minus of 1 upon R plus 2. Now start putting n equals to 1, r equals to 1. R equals to 1 is t1, which is half 1 upon 1 minus 1 upon 1 plus 3, right? What is r equals to 2? Guys, it will be t2 as 1 upon 2 times of 1 upon 2 minus 1 upon 2 minus 1 upon 4. R equals to 3. If you take r equals to 3, it will be t3 equals to 1 upon 2 minus 1 upon 3 minus of 1 upon 5. Don't worry, this is not necessarily that, some number, some term from the first, some term from the next term will be cancelled. No, that is not necessary. If difference of two numbers are there, like in this case 1 and 3, right? So you can see this 1 upon 3 is being cancelled after one term, not with the next term directly, but I think you are getting it, okay? Not directly in this, but you will be cancelling with this. It's okay. Let me write one more term. Let me write r equals to 4. So that will be t4. That is 1 upon 4 minus of 1 upon 6. Okay? Now keep going. Let me put some r equals to n minus 1. We know because there will be total of two terms from the starting and the last term. So I am taking n minus 1. So what is tn minus 1, guys? It will be 1 upon n minus 1 minus of n plus 1. Lastly, r equals to n. So tn will be 1 upon 2 divided by 1 upon n. Okay, 1 upon n minus of n plus 2. Was that clear? I hope it should be clear. Anyway, on that note, what we can do is, this is TR, right? This was TR. If we were to add all the T1, T2, T3 until Tn, what we get is 1 by 3 will cancel with this, 1 by 4 will cancel with this, and so on. Keep going. Pattern is something like this, right? So what do you understand is that 1 by n will be cancelled with this, not 1 by n, right? Not with 1 upon n plus 1, but with this term, the above term, and similarly this term. Sorry. Like this term. Okay? From the starting, if two terms are being left, definitely from the ending also there will be total of two terms will be left. So what is Sn now? Sn will be 1 upon 2 half of, see, 1 plus 1 by 2 is 3 by 2. 1 plus 1 by 2 minus, in the end we get 1 upon n plus 1 plus of 1 upon n plus 2. Right? Anyway, what is the value of n? Guys, 49. So let me write here 49. That will be better because carrying over n will be a difficult task. 3 by 2 minus of, what is this? 49. If we were to take 90, how much? 49, sorry, right? So n equals to 49. Here it is 1 upon 50 plus of 1 upon 51. One upon 2, 3 by 2 minus of 51 into 50 divided by, sorry, this will be 51 plus of 50 divided by 50 into 51. I think rest is just solving here. You can solve this, okay? You can solve this. Method is important and intermediate steps that I have to tell you. Any doubts, Ceylon? So once, just one more time, what we have covered today is, first of all, AGP, right? Arithmetico-geometric progression. How we identify this kind of pattern? There will be total of two things, right? Something will be multiplying, multiplying and multiplying. That is nothing but GP. Something will be like adding and adding and adding with the same difference. So that is nothing but the AP part. How we solve that? We multiply with the common ratio and keep the like powers below the same power, right? Below the same term. And then we can solve it. Then we have seen spatial series as type 1 and type 2. In type 1, we have numbers like 1 into 2, 1 into 2, and or any kind of pattern will be there. But in numerator, so very easily we can solve it with the sigma operator. Is that clear? Sigma operator. Then type 2 type 2 is basically when we have all these same numbers, but in the denominator. So we cannot apply that particular formula. Here we will split the terms and then we will solve. Is that clear? Just one more, that is not necessary to solve, but still I'll take. What is this sum? 1 upon 1 into 2 into 3 plus 1 upon 2 into 3 into 4 plus 1 upon 3 into 4 into 5 and so on. And terms. Okay. So again the same thing, like numbers are being multiplied but in the denominator. Same method, same thing you have to do, right? We will split. But how we would do that? You see, TR is what? R into R plus 1 into R plus 2. Right? Now how we will split? That is important. TR will be splitted as when there are only two terms, right? When there are only two terms, we split into 1 upon R and 1 upon R plus 1 and put minus sign. If there are, suppose there are a total of 3 numbers in the denominator, then how we will do that? We will write it as initial 2 numbers, combination of initial 2 numbers, combination of last 2 numbers, and we will put minus sign in between. Some of you have got it, don't worry. Rest of they will also get it. Rest of the students, they will also get it. TR will be 1 upon R times R plus 1 minus of 1 upon R plus 1 into R plus 2. This is how you split it as. But I'm not saying that it has been balanced. You should always check for the balancing part. Is that true? Yes. Because in the denominator you will get this thing, no doubt. In the denominator you will get this thing, R plus 1, R plus 2, if you will solve it. But the problem is, if the numerator is 1 or not. So let me solve this. It is all rough part. Always remember this is all rough part, right? R plus 1, R plus 2. And in the numerator it will be R plus 2 minus of R. So yes, 2 we are getting an extra, so we have to divide by 2. Now this is your TR. Please look into this. This is how we find TR. TR will be half of 1 upon R into R plus 1 minus times the last 2 terms. The initial 2 terms, the last 2 terms, and what we divide actually, let me tell you now. We divide actually always last minus, this term minus this term, basically the latter minus initial, or if I were to say it, anyway, I'm not giving any name because there will be a lot of confusion then, right? You just remember what we are dividing with, as in this case 1 upon 2, what we are dividing is always the difference of these two numbers, like last number minus the first number. Okay, let me write here. Last number minus first number. But do it smartly, please. Do not just follow this blindly. Okay, we will divide with this. Always remember, 1 upon last number upon first number. If only two numbers are present, then directly r plus 2 minus r, so that is again 2. If we have total of 3, so what is the last number? R plus 2, initial r, so that we are dividing is r plus 2 minus r, that is half. Is that clear? See, understand the concept, okay? Do not just mug it up. I mean, all the time you have to do like last term minus last number minus first number. That is not a good idea. Okay, almost we are done. Now, r equals to 1, tr. Let me write tr. 1 upon 2, it will be 1 upon 1 into 2 minus of 1 upon 2 into 3. If r equals to 2, it will be t2 equals to 1 upon 2 into 3 minus of 3 into 4. If I were to write r3, it will be t3 equals to 1 upon 2, 1 upon 3 into 4 minus of 4 into 5. Okay? R4. T4 is half 1 upon. So keep going basic. There is no need to write it. Okay? No need to write it. Let me write directly. R equals to n. So that we will get Tn. Half of 1 upon n into n plus 1 minus of 1 upon n plus 1 into n plus 2. We are just putting n wherever r is there, right? Now, if you were to add all the terms together, it will be Sn in the LHS in the right side. Let's get the pattern. This is 1 upon 2 into 3, 1 upon 2 into 3, 1 upon 3 into 4. So, yes, they are cancelling each other, right? They are cancelling each other. So, how is the pattern being followed? This way. So, this will be cancelled. What we are left with? We are left with half of 1 upon 1 into 2, the very first term and the last term. Okay? So, that is the answer. Sn will be half of 1 upon 2 minus of 1 upon whatever, right? N plus 1, n plus 2. You can solve this. That will be your answer. Silong, please come with the doubts. No doubt. Very good, Silong. Very good. Okay, I think we are good enough in this kind of problems. Now we can do this, like. Please, just a small break for 5 minutes. Get refreshed because we have to wrap up by 5:30. But still you can take a break for 5 minutes. Okay? Now we are done with all kind of series, don't worry. Now we will discuss your doubt. We'll take all of your doubts, including 9.3, 9.2, 9.1, 9.4 and miscellaneous. Okay? And also now you can solve 9.4. There will be no question in which you can have doubt. Almost all kind of categories I have covered. So please take a break for 5 minutes and then ask me your doubts. Today we will wrap up this chapter entirely. Okay? In the next class we will start binomial theorem. And after binomial we will do PNC, permutation and combinations. And when you are back after break, please just give me a message so that we can start. There is only one center today live for, okay? Guys, do you need more time? Or are you back? Please respond something. Silong. Yes, exactly miscellaneous, right? We were on miscellaneous. Okay, great, great. Miscellaneous exercise. It was question number 16. Okay, question number 16. Okay, the question is, Let me write the question. Question is, if A times of 1 upon B plus 1 upon C, the other term is 1 upon C plus 1 upon A, and C times of 1 upon A plus 1 upon B are in AP, then prove that ABC are also in AP. Okay? Prove that ABC are also in AP. So always remember, whenever we are talking about AP, that means if I say ABC, ABC is in AP. So that means we have to use or we have to prove B minus A B minus A equals to C minus B. If it is given in AP, then this is where we will start from, right? By writing difference of the first two, difference of the last two. Or if we have to prove, then again, at what end we will actually prove? We will start solving and solving and solving, and we will conclude that, you see, as we are getting B minus A equals to C minus B, that means A, B, C are in AP. Or if A, B, C are in GP, right? So what we will use is B upon A equals to C upon B, something like this. Common ratio, simple. Let's start with this now. We are given that these two terms are in AP, so we can use that T2 minus T1, right? Let's solve. B 1 upon C plus 1 upon A minus times of A 1 upon B plus 1 upon C. It has to be equals to C 1 upon B 1 upon A minus of B 1 upon C plus 1 upon A. Okay? So now, let me solve this. This is B of B times A plus C upon AC minus of A times B plus C divided by BC equals to C times A plus B upon AB minus of B times A plus C upon AC. Simple calculations, nothing, right? Now, if we were to multiply with this, this will be how much? AB plus of BC divided by AC minus of AB, right? AB plus of AC divided by BC equals to CA plus of CB divided by AB minus times AB plus BC divided by AC. Is that clear so far? Okay. Now you see. Let me do LCM. If we take LCM, it will be ABC in the LHS, and what we get is B. So let me multiply with B here. It will be AB square plus of B square C minus times. It is what? A. So it will be A square B minus of A square C equals to, in this side, again it is ABC, and it is C square A plus of C square B minus times AB square minus of B square C. Is that clear, everyone? Now you see, we are close enough. ABC gets cancelled, and let me see how many figures we can cancel apart from this. C square A, C square A, C square B, right? This is what B square C. So nothing, we cannot do nothing, right? We cannot take subtraction, or we cannot subtract any of these two terms. So now let's start taking common. How we will take common? Let me write first of all B square A minus of A square B. Okay, I'm taking AB together, and then we have plus of B square C and this is minus of a square c, right? Similarly, here also c square a minus of b square a, and then c square b minus of b square c. All right. Next is, if we take AB common from this, it will be AB common, and we have B minus of A. If we take from this C common, we get B square minus of A square. Here, if we take A common, it will be what? C square minus of B square plus of, if we take BC common, it will be C minus of B. Good so far? Please tell me, because now we are almost done. We are writing down the final answer, almost. Okay. This is A into B. This is B minus A plus of C times, what is this? B minus A, B plus A equals to. Now this is what? C plus B, C minus B plus of BC times C minus B. All right. Now guys, please look into this figure. This is B minus A and B minus A. So in this side, LHS, we can take total of B minus A common, and what we will left with? AB plus of C times A plus B. Please, V minus A I have taken out from both the terms. The left term are AB plus of C times of A plus B equals to. Similarly from this, if we take C minus B out, it will be C minus B, and this is what? A times of B plus C or C plus B, whatever, plus of BC. Right? And please notice this, AB plus AC plus CB, AB plus AC plus BC, right? What we have is B minus A equals to C minus B. That is, I think this is what we were supposed to prove. Anyway, you can write this as 2B equals to A plus B, or B equals to A plus C by 2. That means we concluded that A, B, C are in AP. Right? As we are getting summation of these two terms divided by 2 as B, so that will be A, B, C are in AP. Please ask your doubts. Well, in this question, I would say there is a lot of chances of doing some silly mistakes. Right? There is no concept. Quite easy, very much easy even, I would say. Simply we are using that T2 minus T1 has to be T3 minus of T2, and that is what we are doing. Rest is all intense calculation, and of course you cannot do any kind of silly mistakes. Silly mistakes will not be allowed. Please, Silong, is there any other doubt apart from this? Then ask me. If not, then I'll give you one last question, that is from 9.4. Probably in that question you may have doubts, so I would discuss it earlier only. No more doubts. Very good, Silong. Then I'll give you one question, okay? Question is, find out this sum. 1 square plus of 1 square, 2 square plus of 1 squared plus of 2 squared plus of 3 squared and so on. Keep going. N terms. You have to find the summation of n terms where T1, T2 are given this way. Now, first of all, we have to understand that why this problem is different from the other, right? See, what happens in general, that there will be a different, fixed pattern, not different, sorry. There will be a fixed pattern that every term will follow of the sequence. Like 1 upon 1 into 2. Next term is 1 upon 2 into 3. So every term is being followed by 1 upon r times r plus 1. Here is not the case. Every term is itself is a summation of some series, right? Like T1 is 1 square itself. What is T2? 1 square plus 2 square. So summation of square of two terms. T3 will become automatically 1 square plus 2 square plus 3 square. So T4 definitely, T4 will be what? 1 square plus 2 square plus 3 square plus 4 square. Can you tell me what will be the TR? Right? TR, any rth position term will be 1 square plus 2 square plus 3 square till r square. You have to understand this. In this question, TR itself is a summation. Right? TR you are not writing directly in terms of r, but TR will be a summation itself. Like 1 square plus of 2 square plus of 3 square till r square. Now we can, so first of all, what we have to do is we have to solve for this TR. What is the summation? Summation is r into r plus 1 to r plus 1 upon 6. So can you solve this one? It will be how much? R square plus r times 2r plus of 1 divided by 6. TR can be written as, this is what? 2r cube plus of 3r square plus of r. You please solve this. You will get this as the TR, that will be 2r cube plus of 3r square plus of r. Now this is nothing but TR. Quite easy now, because SN, when you have to find out SN, that will be 1 upon 6 of, let me take this twice out, and we are having twice of r cube, r equals to 1 to n, plus sigma times, sigma, thrice of r square plus of sigma r, again 1 to n. I think now you can solve this. Okay, you can take 2 out and apply sigma over r cube, then again 3 out, sigma over r square, and simply sigma r. So every formula you know already, you have to just plug in the formula, and then that will be in terms of n overall, right? That will be your answer. Please ask me if you have any doubt, anyone. These are my favorite questions, in which every term is being actually being repeated by some other summation, I would say. Right? Every term is a summation itself. Is there any doubt, Silong? This is from 9.4. Please, when you will solve 9.4, you will find out this problem. Silong, any other doubt apart from this? Please. See, there are a lot of series that we can cover, right? But there is no point of covering all the series, right? There are a total of 8 to 10, right? 8 to 10 types. But I have taken all the important in given an NCERT for now. Okay, okay, all right. Great. Okay, you should do this question. Question is, last question for the day. Question is, find the sum of the series. Series is 1 into n plus of twice of n minus 1 plus thrice of n minus 2 plus. Keep going. Last term is being given as n minus 1, and it is what? 2 times n into 1. Right? So this is what series is given. So please identify the pattern first of all in terms of R. I mean pattern means TR in terms of R, and then you have to apply summation varying from R equals to 1 to N. Again, see, in this problem, finding TR is not a difficult task, but don't get afraid of this N being placed, right? Because there will be already some N. There is already some N, right? Total number of terms, if I ask you total of terms, that will be N. How we are getting that? 1, 2, 3, N minus 1, and lastly, from this first number, we are getting N, right? So total of N numbers are present and terms are present. Okay. Now you see how we would write TR. Okay. TR is very much important to write. R times R. Okay. We cannot understand by this. But if you look into this, it will be nothing but R times N minus. You see N minus R plus 1. Is it true or not? N minus R plus 1. Because when you are doing 1, right, R equals to 1. So it is R equals to 1. Now N, in the next term, something is being subtracted, N minus 1, N minus 2. So how they are varying? N minus R plus 1. When this is suppose T2, so we are getting, when this is 2, we are getting 1. When this will be 3, here it is 2. So if this is TR, so this will be R, but this will be N minus R plus 1. And now I think we are done. You see, what is TR? TR will be N times R minus of R square plus of R. Or, better to write, R times of N plus 1, okay, minus of R square. Now what is Sn? Sn will be summation on R into N plus 1 from R equals to 1 to N minus of sigma over R square, R equals to 1 to N again, right? The most important thing is here, guys, we can take N plus 1 out, as the argument of the sigma operator is R. So whatever the changes you will do or whatever the limits you will provide to R equals to 1, then plus 2, then plus 3, that will not affect this N plus 1. Is that clear? Only on R. So this is, you can solve further now. Minus of sigma R square, R equals to 1 to N. This is the answer. Is that clear? Now you can find out the answer in terms of N, of course. Okay? Please, we are done for the day and we are done with this chapter completely. Now if you have any doubt, just come with the doubts. Rest is your sincerity and how much you will practice on this. Because I have taken almost 4 to 5 lectures. Right? That is more than enough, guys, seriously. Please, ask me your doubts along. No doubts? Very sure? And also, please, if you want any of the center, I'm not sure how many of you are live, but if you want me to upload something, right, to say something, please just remind me on the group. Please be active. I mean, especially in class 11, there are no student I have seen, those who are very, responsive, or they are asking their doubts regularly. They are not, I don't know. I mean, maybe your parents have your mobiles and you're using their phones. But fine, take a time, decide a time, like in between 7 to 8 or whatever your time you will be comfortable with that, like 9 to 10. Mom and dad, I'll be having your mobile because I have to ask this doubt, right? There is total of these doubts. Any of the book, if you are following, you can ask me. If you want more question, you can tell me. But be active, right? Because in 1.5 hour class or 2 class, I'll try to provide from my side as much as possible. But that is not more enough. I mean, that is not enough. Right? Maths is not that easy subject. Like I will not compare with any other subject, but definitely all of you know already, right? How much this takes, right? Maths, how much takes, right? A lot of efforts, definitely. Being a mathematic, I mean, a maths teacher, when I was a student, so I was good at chemistry actually. But I never gave up at mathematics, right? Because I was good at maths, but I was not scoring good enough as much as in chemistry. That happens, that is actually the case, right? Because those who will actually got like the same marks in chemistry and physics, I mean, same marks in maths as they are getting in chemistry or physics, they will be topper. Because maths is always less scoring, but that does not mean you should give up with that, okay? Math is something, if you are into science field, it will be helping you a lot, entire your life. But not with the sequence and series, of course, in general mathematics, okay? Anyway, take care everyone. And if you have any doubt, just ask me on your WhatsApp group. I'll be telling you all the doubts, all the solutions there. Take care everyone, take care of your health, travel safely, and we'll see you in the next class. And in the next class, we will start binomial theorem. So please you do some pre-readings from NCERT. In all these schools, most of you have covered this in these schools, right? So please do some pre-readings so that we can, some basics, we can finish it in, one class or like middle term, general term, how many terms, expansion, all of this we can cover in the first class only. Okay? Please, if you are there, Silong, respond something and then we'll wrap up. Silong, are you there? No, you are not there. You must be there. Well, I cannot see any. Okay. Thank you, Silong. Thank you very much. Now you can leave, as it is being darker, getting darker, so you can leave now. Thank you. Good night, everyone.